Wait, is it?
It's right there.
Oh, this one. Oh.
On track.
He was looking on the roof like, it's not a good.
Okay. Okay, very good.
How did
Lenses.
Live on YouTube.
Nice. So are they gonna join and just like go online, just like?
No, it
Okay,
was,
my friends, back
was,
here.
It was there on
No
YouTube.
computers, back here.
Okay. Yeah. Okay, are we good? Perfect, guys. So let's get started. So today we're gonna intro something that you can build yourself. So like it requires some decent knowledge of the robotics, like so how certain elements and pieces working, 3D printing, and just the best idea, like your best friend is your imagination. So we've seen the picture, you guys seen the map, so like you know a lot more than me. So like in this side, okay, so how do we build that stuff? So what was the idea beyond that point? So we decided, okay, we need to shoot the ball. So what do you have? You have a pipe. On the pipe you can have cut the hole, and you could put like a wheel from the car, so when it spins, you just have the ball coming, it comes to the point, so like, and it will be shooting, right? So that's your gun. It's like pretty much like, that's what you can do. So that's when I was a kid, that was my gun. So, but you need to have some controls over it. So like you need to be able to turn it left and right, up and down, right? So like it looks very simple. You guys like, you may think it's like it's very simple. It isn't. So it requires decent knowledge. And when I was a kid, so like we were doing that at the age of 19, 20. So the technology wasn't there. So you guys are lucky to do that like at the age of 12, 13. So you need to have two motors to control that in order to do so. So what was the solution? Let me show. Like just open the bag step by step, and that's pretty much the solution. That's how it looks like. Have so many wires here, so like some of them disconnected. So let's take a look, guys. So like how things look like. So how your solution gonna look like? You have a joystick. This is how that works. You know that you all play computer games, right? You know how that works. How?
Push it to the side.
So like you push it to the side, but what happens internally?
Push it something.
Sounds like a command.
No. So internally, so here you have a couple potentiometers. So these things, you see that? Just come closer. So this is the potentiometer. It changed the impedance, right? So like when you rotate it. So when you rotate it, it can, let's say, just change the impedance like from 0, let's say, to 1024. So like, and you can say like, so like, this is how you can control it. So here it's exactly the same thing, but the difference between this device and this is different. So this returns back because like it has a spring internally, right? So that's why it comes back. And here's only one. Here you have two. So I have X axle and the Y axle, right? So like you have two. So like that's how you can control that stuff easily, right? Kind of clear the idea, right? Okay, let's move on. What else do we have here? So like, can we use the potentiometer just to connect straight to the motors? Can we? No, unfortunately no. Like the servo motors that we have here, they have a digital control. They have two wires. One is ground. You have +5 volts, like for this in particular, and I have a message bus. So the control unit, the control wire. So, and unfortunately to say, you cannot connect the potentiometer straight to the motor, so it simply won't be working. So you have two options how to connect. You can have like a control board, which will be containing like a number of potentiometers that you can easily rotate them, and it's going to be just rotating to the place you need. That's the A option, right? And in that option, you can easily say like, so like I can just rotate the pipe anywhere I want, and it's going to shoot the ball. So technically, let's take a look step by step what would be your algorithm in order to make it work. You install it this way, so like it's a little bit up, so the ball gonna be secured at that elbow, right? So when you just like make it straight, or just flip this way, so what's gonna happen? The gravity force, just move it down, right? So like if you have a spinning wheel, it's gonna be going faster, but like if you just do it this way, so like the ball will be just released from the pipe and it will be going straight to the target, right? You don't even need to have a motor. So that's why we didn't put that first in the water, but you guys feel free to. So how do we control motors, right? So like I said, that motor is not gonna work. So let's talk about which motors do you guys know? Electric motors. No? Okay. There is a DC motor. So this one has 2 wires, has no control. So put 5 volts on it, ground 5 volts, and it starts just spinning one way. So like the rod, right? So that's all it can do. You can put like a fan on it, like whatever, like the ventilator, so like it's gonna be just blowing air to you. Can you control that thing with this? What's gonna happen? It will be just constantly spinning. You won't be able to control that, right? Okay, people decided, okay, so why not we just introduce something new and just find the other solution. So they introduced something called, you need to,
Behind what?
right?
Can be free, like in
Right. So they introduced something called servo motors. Servo motors can rotate from 0 to 180 degrees or from 0 to 360. Do a full circle. But it's not going like and spinning all the time. So no, it's just like, you can say like to what extent you would like that to be turned. So how does it work? Let's say you have in this position that's your 0. Or let's say this is a 0. So this is -10. This is like a 30 degrees. So by having the control of the motor here, you can easily say, so like, which position you would like that to take, right? So it's very simple. From the programming standpoint of view, or just from your thinking, you know, like, say -10, say 30, say 0. So that's very simple. You can just draw it on your paper, like you can say, okay, I know how to work with that. The logic is very simple. You can explain it if anybody would ask your question. So how that works, you're saying, we have servo motor, we have a 2 power, 1 control wire. Then we are saying this, so like it either stays this way or the other way. Very logical, right? Okay. It's pretty much what you're doing anyways. So that motor is not going to work, so like you'll need something like that. So this is where the complexity is coming from with these motors. So like it can be either controlled for the controller, which has 2 potentiometers which rotate, and then the platform gonna be just rotating. So you have one at the bottom here, as you can see, one at the top. So the bottom one is responsible for the platform just to go around, but the platform go around only like 180 degrees. So from this position, like all the way up down here. Okay, so it's technically, if you put a pipe, that's the only way it can go with single motor. You have 2 motors. Second motor is this. So like technically, this is where you have like a second freedom. So like it can go, like you can control vertically. And this is where the joystick is coming to, I would say. So when I'm just pushing that up, it triggers the top motor to go one direction. So you put that down, it goes the other direction. So you put the right left, so the other motor is just going to the other, right? Very simple. Okay, but what's the complexity in this project? Let me explain it. This is all student grade quality, means no quality. You know, you guys know what the interference means? No? It's just when the signal goes, let's say, a straight line, and interference just making that shaking. So you never get, if you put like on the input 100, so like it never comes back as 100. It's going randomly, and you never can control. And this is the issue that I ran last night, and I was just finalizing the project. I put the joystick in, put the software in, run it, try to guess. It was shaking all the way out, so and the pipe was falling off. So I decided, okay, so that's not gonna work. So we'll get into software, so we'll talk about how that needs to work. But you can see, so like certain things will be flaky, and that's what you will be dealing with mainly at your competition. So like when you will be displaying your project, so it's not gonna be perfect. It will be shaking, falling apart, most likely, but it needs to be like that. I don't know, like if you like to build like a production grade, go to the factory, just order like these elements and say like you guys build it yourself, like design absolutely everything. Nobody's gonna trust you. That's my personal opinion, but like again, we've been through that like a Lego competition 2 months ago. Certain teams were definitely coming with kids designing everything. So the other teams were coming, try to guess. They're just coming with robots definitely built by people who know what they're doing. Our team, Danny and just the rest of the guys, so with Zor, so we came in like with the robots, we made some guidance, some recommendation, but it had never been like fully built by us, so like we weren't here, so we never done it. So guys, please make sure you understand the fundamentals. So what the fundamentals means, you have the bottom motor, which is servo. It allows you to rotate 180 degrees from left to right and just spin the platform. So you can choose the direction. You have second motor, which sits on the platform. It will allow you to control the pipe and just pretty much like control the gravity force that just applied to the ball, right? Okay, you guys cool with that? So like any questions so far? No? Cool. So now let's talk about the complex stuff, because all the wiring, we'll discuss that in detail, so what means what and why it's connected this way. So with these motors, because these are 5-volt motors, that is not going to work. So Zor has smaller motors, like, and we need to design for those, because the other motor is going to work. So like this AC adapter is sufficient only for this in particular. So if you'd like to control anything, that's not gonna work. So this AC adapter also not going to help. Even like on a breadboard, if you're gonna connect that to the power supply, that won't do anything. What's the reason why? Again, not enough power. So for those servers, right?
So we need like different motors.
Exactly, yeah. So like Zor has like just a smaller motors. So in order to make it work, so like we have that AC and DC converter. So, and that's pretty much like, so we're getting to the most interesting part of the project. So like it's pretty much like we need to put all the things together and discuss how that's going to be working. So let's move. So we have a couple of AC outlets here. Yeah. I don't know how you guys are gonna be just assembling that stuff, but you will need to figure out. So like technically, USB will not be enough. You guys need to learn how to put stuff together. So just run those servo motors. There are adapters for like 6 batteries, like 6 AA batteries. So like you can put like a 9 volts, but like the power will be just a lot more than these batteries. So like this battery is only for running like the logic board, that's it. Come on. No, it just doesn't have a ground connection. I'll try to connect this. How much do you know, guys, about the programming in general? Like, so do you know how to use the Arduino? No? You don't? If anybody would ask you a question, so how did you guys do it? So like, what would be the answer?
Zora told us.
Zora told us.
ChatGPT.
No, we have 2 agents.
You don't want to say that on... Oh. like at UFC, right?
I don't know. We just tell that
We just knew.
no, because
Oh,
AI,
yes.
AI knows.
Yeah, that works.
Well, somebody knew. Then just had to. Oh.
Somebody told it's not going to work, guys. Like, so it's just one of those things when you need to figure out and say like, okay, guys, like I know how that works. They might not be drilling you questions like so if you understand like exactly everything, but at least you need to say so what this element is. So what's the name of that element?
It was like a E something motor.
Servo.
Circle.
Servo. Like if you say servo, so like they will just get off your shoulders, let's call it this way. So like it's just like this is like a servo, like and it's saying like so it's 996 model, so like there's a servo 9 that Zora has, like so like it's very much like a third of the size. It does exactly the same thing. The only difference is just why this one is bigger and the other one is smaller.
One is stronger than the other.
Exactly, a lot more powerful. So it's pretty much like what you need to know, like and so what you need to play with. So how that's going to be connected? Let's talk about this. Some wires here. So you see, these are the power connectors. So like they're of these motors. What's the reason?
What would you say? You get power from the motor?
Yeah, not enough power from the battery. So Zor, this battery not going to work most likely for everything. You'll need to find out like the 6 battery pack for Arduino with the same connector.
6 battery.
Or just measure so what they will need, because technically I failed with everything. So like even the like this, the Arduino power supply did not work, not enough. Who guys know how to use this?
You need this one on to give it more
Okay,
power.
okay, so like that's the first one, so what do I do next?
You press one of the buttons.
Okay, press this button as well, so okay. Anything else?
Nope.
No? Yeah, we don't have problem. So technically, this is like this called like a programmable power supply unit. So we can say like how many volts and amperes you would like to get in there. So like, and you can control so what exactly you need to do. So it will show like the diagram here, what will be the power consumption. So one of the first tools, like when you work on robotics, so like that's one of the basic stuff that you need to know about. So who knows like which is which? Why there are 2 colors, black and red? Simple question.
One's like inputting the
Yeah, and
volts
like it's-
and the other isn't.
Okay, so Helen, this called ground, this one called +5, right? So right, so like ground, positive, negative, positive. So every DC battery they have plus and minus, right? So it's the same idea. So here you can see black and red. So like if you know if it's red, then it's plus, then it's black, then it's ground, negative, right? So how do we connect? So we have here the motors have exactly the same connection. So I have like all the rainbow colors. So like I had hard times to find like the right colors last night. So like I put the random ones. So but you can trace it down. So I have blue connected to the black, and we connected here. So like in the second motor, we have green connected to it. So here, anyways, this is the connection. You see, it's all flaky. I don't think your stuff gonna be any better, guys. Like if you build it, so like I really would like to see like how you will do that better. Now, positive, right? So we connect the positive one. So like a red one is connected here, and here we connect. Here we connect the red one. Okay, and here we connect the black. Painful. Okay, so this is what we have. Like it doesn't do anything, right? no control, the motor does nothing. So like, we'll disconnect this for now, so like, we don't need that. So just nothing happening, and just like even here, so nothing. Let me connect the battery to the LED group, like whatever, like Arduino. Nothing happens. Why is not happening?
Power supplies now.
Correct. Turn on the power. Come on. No, it's not gonna work this way. Okay guys, so like even though we will just enable and run it, you see? Now that's coming to the point. So just turn that off. We're in that anywhere. And it's coming to the point where it says, so the program says come back to 90. That means it's just like we're leaning up vertically or just straight to the point. So like it's a little bit misaligned, but you see the idea, right? Like I said, how the motor behaves. I'm just rotating that, running the up, just rotating, right? So right now the program is just connected to this. See that? I just pull it down and it just goes. So I just rotate it to the right, just goes this way. Just a little bit hitting the bolt is hitting the one of the gears out there, so that's why I just like it making that noise, but the whole idea, like you see that. Would that work for you guys? Is that gonna be enough for you just to make it running and just like, do you know how to use it afterwards? So let's say that's your just like PlayStation. You just connect it and just like control that, right? So we just put the pipe on it. So like we connect and just run it, no? Is it gonna be working? No, it's not gonna, right? So like at the PlayStation, you can stop, you can just aim, right, and then shoot. That's not gonna work. There's a problem. So what's the problem?
Can't shoot.
Yeah, can shoot. No, if you can put the ball in there, so like it'll fall off either side. So the problem is, it just totally aligned with a joystick. So like, it knows the kind of like the start position, so which is like 90 degrees here, 90 degrees here. So like it's all sits this way. I'm start rotating, so it's either goes either way, right? When I just release the joystick, what happens?
It keeps going.
Goes back to the standard, right? So like to the 0 position, so which means like 90 degrees both ways. So we need to change the program, how the program needs to work. So let's talk about this, because like this is the most complicated part, and just you probably won't be able to figure out that like until you start like really drilling for the stuff. So the PlayStation, it doesn't really align you like so whenever you do this, right? So like it does a little different thing. What's happening out there, if you just push the joystick up, down, left, right, whatever, it knows the direction where it's all going, and try to guess what's gonna happen afterwards. The program has counters. It says the longer you hold, the more upwards you're going to look like. The hold down, so like the camera will be going down, right? So like that's exactly the software we need to write, right? So it's pretty much, we can put down there. Give a second. We'll just update the code. I haven't tested it, so like we'll see if it's gonna be working or not. So like it may fail. It might, I don't know. We'll see. compiling right now. That's good. Now we're just following. Okay. Doesn't do the right one. No, it doesn't. Anyways, so we got to troubleshoot that. So, but the point how it's supposed to work. So when we come to the point, it's supposed to, like, when you just turn right, the longer you hold, it will be just like rotating to the right, to the left. Unfortunately, like, I couldn't accomplish that yesterday. I'll finish it anyway, so like I'll show you the program afterwards. So let's talk about how you would just decide, so how exactly you guys need to aim to the point and what needs to be done. Because again, if you have the machine, even you hold it and it just rotates the camera left or right, how do you know exactly where to shoot? Who's gonna tell you that?
Oh, you can use like laser pointer.
A laser pointer.
Yeah.
Okay, one of the options.
You just like cover it first, and then you just press the button.
Yeah, just like unfortunately, yeah, this one is not shown as well.
But you just don't need a joystick, and you just go down.
Can't we use an ultrasonic sensor
No,
to use the distance?
no. What you can do is just like I just put the small LCD display here, so like which is technically 16 by 2, so like you have 2 rows and 16 characters on each line, and we can easily show, so like pretty much the position where the currently the motor is. So how does it work? You start from the 0 position. I have 0, 0. Right, so let's say like it's just bottom right, bottom left, whatever. And you're saying, so like in order to shoot the first target, so like where you need to be? You need to be, I don't know, like a 30 degrees and -10, so you can load the gun, right? So the second one, so the shooting position, 30 degrees, like on the horizontal side, the vertical is 30, like whatever, like 30 degrees. So like it'll flip the gun. So from this position, it will flip the gun, and the ball will be rolling or flying to the point, right? So let's talk about the second one. So like it's exactly the same thing. You go -10 position, you rotate, let's say to 45 degrees, whatever, load the gun, shoot. Third one, you load the gun, shoot to whatever, like 60 degrees. How to hit the goalie? How to get to the net so not be caught by goalie?
Okay, take the time.
Shoot it really hard.
Calculate the time, right? Correct. So like you need to know distance, you need to know the speed of the ball, right? So like it's gonna be rolling. You need to measure the timing. I don't know how the goalie gonna be, just like moving right and left, I don't know. So you set to the point, so you know how long it takes just to flip the gun and just let the ball roll in order just to get to the net, right? So it's pretty much your project. Questions, guys? I know it's not super interesting, like if you're not touching it. So, but let's talk about so. What do you think, guys? It's gonna be? So, like if you're gonna be building, so let's talk about your project in particular, because you guys are gonna be building, right? So, what you would like to build, and so if you have any questions, because if you look, this is the platform. You have it, right? So this is the one. You have a motor here. Would that work? You see? No. You need to have.
Full rotation and you
Yes.
stop.
Yes, it's gonna be spinning. That's the motor just for the vehicles, right? So you drive the cars. So how to install this, right? So like it's very simple. You have platforms for the servers, and you can just like easily just put 4 screws in there and put the server below, and it's gonna start working, right? This is for the big one. So on the other side, so the other servo motor, it needs to be on the side. Would that be sufficient? Can you mount that here? Probably not, right? Like, well, you can, like if you put like whatever. Like I went Home Depot yesterday, so I got like these, like I don't know what's it called, this. I don't know what's the English word for that.
Metal zip tie?
Zip tires, whatever. So that's the why I secure stuff in there. So like that's how we guys were building prototypes and like all the toys when they're just kids, right? So like you're a kid, you have nothing, you have no money, you have just imagination. Go with something that would work. So like that's my child. So, and that's how we were building stuff. So in your case, you have 3D printers. So like we didn't. Like so like you just like you have a knife, you have a piece of wood. So like go figure it out. So same idea, very much the same result, but we're getting closer. So you will need to have the model here. So that's gonna be. Yeah, I will need to fix the software. So like, and I will provide it to you guys like in a fully working version. So like with all the details, how that works, and all the highlights. Because again, so like it's a little bit funky right now. Like you can see, just like it doesn't really do like what I would like that to do, but like it's close. So, and you will need to have several supply units, like power supply units. So one you will need for the Arduino board. So which is 9-volt batteries will be enough. If you'd like to do the 16:2 LCD, yes, you will need to have the second. Well, it's actually no. You can use the same 9-volt battery from Arduino. So like, and you can just put the power in here. That's gonna be enough. For the potentiometer, and like so, like it's pretty much like that's your like it's an optional stuff, but it's good then you have a contrast, so like you can control that. So like it really works well, because like otherwise you might not be able to see that. On the other side, servos, a separate unit to have that control. Okay, so it's pretty much how your project needs to be. So since it's like 30x30 machine, right? You have a platform here where you will need to figure out where you guys place all the controller units, because you will need to have breadboard, Arduino. That's what I call interference. Everyone is just like, you guys know that you can bypass the electricity, right? It just goes for you. You can test it. That's the way it works. Just 5 volts, it's not going to kill you anyways. So, you will need to secure it somehow. And the joystick, so it's this, right? I don't know what that is. It's getting closer. You can see just like it's trying, but again, so like I'll fix the software. It's just like one of those things, but it's pretty much where you guys will get it. Want to talk about wires and how that works, so you just would be completely lost today. Completely lost. Just again, so like the controlling the various units is just like it's not any different, rather than pretty much playing with LEDs out there. So why is that? Let's talk about like how to control that. So if you know how to control the LED, right? So you know like which signals do you guys know? So like we'll start from here. You know, like there is the analog, right? And there is a digital. What's the difference?
Digital is like in the computer, like the motherboard.
Okay. In electricity, the digital is 1 and 0. So it's saying like, so like if it's voltage is here or here, that means 0 here, 1 here. So like 1 and 0, you can control that. The analog, like you can just put the higher voltage, more power, right? So like, and just like from that case, it's gonna be going like, so technically what Arduino board can do, it can control and convert the analog input, which is this, because the potentiometer, that's the analog device. So it tells back the analog signal to Arduino board saying, this is what my current value is, right? So from that value, you can say, so let's say like, so like it say like 500. And when it's 500, like so you can easily say, let's say like that 500 will be equivalent to 90 degrees. So like, and that means like, so the joystick stays in the middle. So if it's saying like my value is like 750, you're saying that's like maybe like 135 degrees out there. So like, and you just rotate to the right, 45 degrees. So, and that's pretty much what Arduino is good for. So like you get the analog signal in, and you can put the digital signal out. So by putting like the signals to the LEDs, you can learn how to control the other devices, because it's not any difference. The only difference, you will need to use different libraries. So the server engines, they do have a separate library, so like you just include it, and like it's very simple. You're saying like, this is my servo motor 1, which sits on a port 5, in my case on a digital port 5. And that's the value I would like to set. 10 seconds by or 50 milliseconds by, you would like to change the value, so I can just make it work. I'll be just rotating back and forth. But again, so servo motor, like especially the ones that we have, so like it's not gonna work out anywhere beyond 180 degrees, because that's exactly the model that we're using. DC motors, spinning the wheels, and the third motor, there is 2 of those on a printer. They called step motors. You know what the why it's called step motors? Because you're saying so, do that many steps, that way or the other way.
And each step is you set up as degrees, right?
Like these ones, yeah, the service has degrees. Service degrees, steps, you just turn it on and off.
But how do you define step?
Oh, it's on those, not on this. Those don't support that. So Tesla is, which motors? They have 2 motors. Which ones are those? DC, step, or servo? So which ones? DC, right? So like they just rotate indefinitely, right? So like,
So
but
the DC goes several way.
correct. Yeah, you need to use servos. Yeah, you need to use servos in order to connect things. So just rotate the platform, etc. So a little bit of techniques here, because again, you guys, it doesn't mean like if you put all the things together, it's going to magically work. It won't. So the first thing, like before you will get started, you will need to set up like the zero ground. So pretty much like the starting point, from there you need to start. It's not only in the program say like that's my 0, that's my this, right? You actually will need to turn on the software, run that for calibration to the 0 point, so like you put that to the 0. You mount the platform, you mount the pipe, you mount everything, so like it's in there. So that's a starting point. So once it's ready, then you start working from there. So the best option probably would be, I don't know what will be the rules out there. You put like the base, the foundation, you run the software, by default it comes to the bottom left point, and then you just put your platform on top. So that means you know exactly where it points. When you start using that, you will be using joystick, and pretty much that will be just letting you just to control and point to that. So why do we need to have this display out there? Because this display can show exactly how many degrees either way. So you can put your platform, the base, and you can just start shooting and playing who's gonna hit the card whatsoever. So you need to figure out, so like pretty much which values you need to set. So like if you just like, this is the 0 degrees, 30 degrees first goal, the second goal, I don't know, like 75 degrees, the third is like, I don't know, 98. So you write it down, so whoever will be the operator who will be driving the whole thing, you pretty much will set those 3, you shoot them very fast, like it's gonna be very simple. So next thing, goalie, like we discussed, so you put to the point, you know the timing, use a timer, see how it moves, like how many seconds it goes like left to right. Don't shoot when it's on the very left side, or on the very right side for me, left on you. So like don't shoot it this way, because like if you want to hit here, because if the timing would be wrong, it will be exactly the time. So you need to do the simple math, right? The speed, the reaction time, pretty much how long it takes for ball to get to the goal line, and for the goalie to move right and left. You do simple math, measure it, so like use a simple timer, phone, whatever, and just shoot it. That's it. So it's gonna be very simple. Right? Exciting? No? Alright guys, like you guys gotta love it one day. So like when you start building it yourself, so like it's gonna change the world. So it will be a lot more interesting, a lot more like satisfactory. My son doesn't build that stuff, don't worry about it. He loves to print. He loves to program, but like this, he helps a lot, but he doesn't have that passion like I do. Like so, like it's just nobody's blaming anybody. Like you have your point of interest, so like, but at least we're here, we're discussing. I can answer your questions if you have.
Maybe when they build it, then along the way they will have some question, they will struggle.
Mm-hmm.
Then
We can stop by next Friday, Friday after. So after the workouts, like after the gym, so we can stop by, we can have a discussion. So if you have questions, so like you can just take a note, write it down, so like we can discuss that. So next Friday we'll bring a working version, so like absolutely working, so like we put things together. So it'll be more assembled, and you guys will be able to compare how things will be working. But at the same time, guys, try to learn how to just put the screws and nuts in there, so like it's fun. It's the only time that you will do it for fun. When you will grow up, so you will be either working, you will be told to do so, or you will be building your own backyard and you will be building fence, and it's not as nice as just having fun here. Okay? You're not taking me seriously, but anyways, like we'll talk in 15 years. Okay. Yeah. So that's it, pretty much, guys.
So,
No, it's all good.
so I think those are too small.
No, those are good. Like so, like it's good enough. So what you need to do
It's
just
not
like,
heavy stuff, right?
So it's
So it should be enough.
well, you know what we did. Oh, actually, guys, like you missed one point. So like, please don't think I built that stuff myself. Like so, all the models, etc. So we went to internet. So we found something. So like. Just made something working, so like I cut off the piece here, so like my son told me like I can do better, like can print a better device, so like it's gonna look better. No, we did the funky. So that's coming from Home Depot, so that was just bastardized by me, so like I just like cut it off, so like it's a piece of garbage pretty much. So unfortunately, that's the way you can make it look like you're building that stuff. So don't be hesitant, build something that you guys like. Something doesn't work. Zor, you gotta move that like exactly to the center.
I know.
Oh, you're saying, okay. So, yeah, and securing the stuff, so like potentially, so like there are so many models out there, so like you can find on the bamboo stuff, like so pretty much like you can secure those small, tiny motors.
Mm-hmm.
So don't leave them flaky, because like that's not gonna work.
It's not gonna work.
Well, it's just like it will fall apart, so like the more it's moving, so the less precision you'll have, so it will just run into situation. So when you just like you do all the calibration, you did everything, and it moves 1 mil. Guys, if you just move 1 degree on the left and on a distance of 1 meter, how much on the left it's gonna be? So you have it here, so and you miss 1 degree. What will be the offset at the very end? Geometry, guys, come on.
What geometry? So
smart.
they didn't start geometry yet.
No, you haven't?
No.
No, come on.
I finished.
You finished? So, like you have the geometry, do you?
Geometry?
No, yeah.
Which one is geometry?
Geometry is just algebra and geometry, so like it's not. You
Oh,
don't.
oh,
Don't worry.
that's our next unit.
Yeah, that's what I'm saying. Just too soon for you guys. You don't have that fun, but yeah, you will. So it's pretty much like so by knowing how to control that. So like it's pretty much like if you miss 1 degree or just 5 degrees, so you're gonna be like it will be the ball gonna be rolling more to the left. And why do you think they have such a distance from it? Because if you just shoot it, the less precision you have, you can just like screw things up, and it will turn into situation will hit the wrong person. So this is why you need to have proper calibration. Just rotate it to the point. You know exactly the values, and only then you flip it. Otherwise, it's not going to work. Okay. Cool.
just checking this stuff out.
You wanna check? Oh yeah.
Or not go.
So
Can
we
you
have
refer to your show?
So we have 996 motors here, so like not enough power on the 9-volt Duracell, so like it needs to be like more of the 6-pack of double A's. I didn't have those, like, so couldn't find that yesterday, so like pretty much like around midnight.
Double A's, they what?
What is
Double
this?
A's, like so batteries, 6 double A's,
What's the voltage?
like 9 volts. So in order to make it work, so like you have 2 circuits, so like one is pretty much the Arduino, so like you put up your like one battery here, so that will be enough to run the 16-2, huh?
For how long?
I don't know, like for a long time, so like the consumption is low. So like here you just like put the
You know,
pretty much like on the low contrast, so on low brightness, it's gonna work. So like 200 light ohms is gonna be enough just to dim the LEDs at the back, so it's gonna be good. And so that's gonna work out. I messed it up, so like I just put that like other way around, so like it needs to be on this side, so just to put that stuff, it's okay. So like it was good enough for the prototype.
What is this design? So I'm asking.
Design.
Also like.
So what exactly?
We have
they mean?
Like what is supposed to do?
on the
So,
software, then they can do
2 servers, one at the bottom, one at the top.
Yeah.
So you put your pipe in here. You put your
Controlling here.
yeah, it's pretty much like two.
Yeah.
Yeah, it's pretty much like 2 potentiometers. So like one is just retaining the platform,
And then this is to move the ball.
and no, it's just like it's gravity machines.
Oh, I see.
You don't need it. So technically, if you put that to the point, so like you just like that's enough just to put the gravity in it. I'll just let this start rolling. That's it. That's all. So you have 2 controllers here, so like 5 and 6. That's for the service. The rest is just for the
They can use
this guy, for 16
Yes.
to build.
because it's a 6 like a 4-bit interaction, and pretty much so how many I have like 4 here, just like 2 more. So on 2 controllers, right? So like it's technically it means if you don't build it this way,
So this is.
that's good. You can put laser point on it, just zip ties. That's gonna simplify things a lot. The program is like 40 lines of code.
Okay, so.
Oh no, that's good enough. Look at this.
Wait, so is it live streaming?
Yeah, I think we should.
Oh no, it's a little more. It's a little more.
I'm on live?
Yeah, you're on live.
Live on YouTube.
I'm live.
Wait, let's check.
You're like.